Hi guys, in this video we're going to have a look at how we rationalise the denominator when the denominator is a surd. So if you haven't seen my other surd video, make sure you give it a look. But essentially what a surd is when it's a square root and the answer is an irrational number and basically not a whole number, so it has like decimal places. And what we want to do is rationalise it. So essentially what I want to do is make this denominator, the number at the bottom of this fraction, a whole number. The reason we do this is just to make calculations a lot easier. If you're dealing with irrationals, it's very tricky, it's doable, but it's not very nice. Whereas if it's a whole number, it's so much easier. So that's why we do rationalising the denominator. We're trying to make this number at the bottom of the fraction, a nice whole number. So to do that, what we do is we times it by another fraction, and that other fraction is this square root, so the square root of 2 divided by the square root of 2. Now the reason why we can do this is if I just look at the square root of 2 divided by the square root of 2, essentially that's 1, because how many times does that go into that? Well, it goes in once. So what I'm actually doing is just timesing this by 1. Obviously it's not like that because it's obviously I'm timesing it by root 2 and timesing it by root 2, but that's why I'm allowed to do it, because it doesn't change the 5 root 2, the number, the actual equivalent value is still the same. Okay, so when you multiply fractions, we just multiply the top, which is 5 times root 2, which is just 5 root 2. And we multiply the bottom, root 2 times root 2. Now, if you remember from my previous surds video, if you've got a square root and you times it by the same square root, you just get the same. So that's just going to be 2. Okay, so in this particular case, the denominator is now a nice whole number. It's now 2. Therefore, I've rationalised the denominator. Okay. Let's now go at this one then. So this time I've got root 5 on the bottom. So I'm going to times by root 5 divided by root 5. So again, root 5 divided by root 5 is just the same as timesing it by 1, which is why I'm allowed to do it. 12 times root 5 is just 12 root 5. Root 5 times root 5, using that rule again, is just going to give me 5. This one here, don't be put off if it's 3 root 2. Exactly the same process. I'm going to times both top and bottom by root 2. Which will give me 8 times root 2, which is obviously 8 root 2. Now, root 2 times root 2 is obviously going to be 2. So actually what I'm going to have here is 3 times 2. So 3 is just going to be 3, and then root 2 times root 2 is 2. So what I'm actually going to have is 8 root 2 on top over 6. So just be a little bit careful with that, just an extra step. Same sort of thing going on with this one. I'm going to times it by root 3 over root 3. So 7 times root 3 is just 7 root 3. And on the bottom, 5. Oh, sorry, I need to put that as root 3, don't I? Being naughty. Yep. Okay, so 5 times, and then root 3 times root 3 is obviously going to give me 3. So a little bit of simplifying, that'll be 7 root 3 all over 15. Okay, so yeah, just in case you did what I just did there and forgot to do that root 3, remember it must be root 3 divided by root 3, so you're timesing it by 1. If I'd have left that as just a 3, can't do it, it'll change the value of this. Okay, so they're the easy ones. This is when it gets a little bit trickier. Okay, if you just times top and bottom by root 2, what will happen is that you'll have root 2 times 2 and you'll still have a square root. Okay, if you want to try it, by all means do so, but it won't actually get rid of the surd on the denominator. Okay, so what we need to do is something a little bit different. If I've got root 2 plus 2, what I'm going to do is I'm going to times both top and bottom by root 2 minus 2. So I'm going to change that plus to a minus. And of course, I'm going to do exactly the same to the top. So I'm still timesing by 1 essentially, but because that's a plus and that's a minus, you'll see what happens in a minute. Okay, so I need to multiply this by this. So root 2 times root 2 is 2. Root 2 times minus 2 is minus 2 root 2. 1 times root 2 is plus 1 root 2, or just plus root 2. And then 1 times minus 2 is minus 2. So that's the top done. If you want to use a grid to do that, by all means do so, but I haven't got enough space here. On the bottom, root 2 times root 2 is 2. Root 2 times minus 2 is minus 2 root 2. Then over here, plus 2 times root 2 would be plus 2 root 2. And obviously 2 times minus 2 would be minus 4. So when we simplify that, on the top, 2 minus 2 is obviously nothing. Minus 2 root 2 plus root 2 would just be minus root 2, or minus 1 root 2, but we say minus root 2. Now this is where it's a bit more interesting. So on the bottom, 2 take away 4 will obviously give me minus 2, but this is why I changed it to a minus, because minus 2 root 2 plus 2 root 2, they're going to cancel out, so I cancel out my surds, so I'm just left with the whole number. We can just tidy that up a little bit more though, because a minus divided by a minus is obviously a positive, so we can say that's root 2 over 2. Okay, and there's your answer. You've rationalised the denominator, comes out at 2. Let's just do one more example then. Exactly the same thing here. I've got a 3 plus a root 7. So if I just times by root 7, I'll end up with 3 root 7 at the bottom, and therefore I've still got an irrational denominator, which I don't want. So I can, don't want to do an equals, I want a times by 3, change the plus to a minus. Obviously root 7. Obviously if that's a minus, you want to change that to a plus. As long as they're different, you're in business. And obviously, again, I'm just timesing by 1 because I'm doing that divided by that, which is the same. So let's work this out. 6 times 3 is 18. 6 times minus root 7 will be minus 6 root 7. On the bottom, 3 times 3 is 9. 3 times minus root 7 is minus 3 root 7. Root 7 times 3 would be plus 3 root 7. And then finally, root 7 times minus root 7 would be minus 7. Remember, if it's the same, root 7 times root 7 is 7, and plus times a minus gets me the minus. So, a little bit of tidying up. I'm just going to come over here so I've got a bit of room. Obviously, that's fine up top. I can't simplify anything there. On the bottom, I've got 9, take away 7, which is 2, and then, just as we expected, minus 3 root 7 plus 3 root 7. They're going to cancel out. Happy days, there's no more surds on the bottom. But if you've got something like this, although the bottom number is is now rational, it's now a whole number, we can still do one more step. Because I can do 18 divided by 2 and I can do 6 divided by 2, I can actually simplify that to be 9 minus 3 root 7. Okay, so if you can simplify it like that, by all means do so. Okay, so the answer there would be 9 minus 3 root 7. So that's the basics of rationalising the denominator. Hopefully that helps. Cheers, guys.